which we drew and discussed. It is the Greek letter for that we choose to represent angles. So we start with that. And of course, everybody has already done this, so I can go as quickly as I need to. Theta equals 30 degrees. Then I have one side. That side is an adjacent side of 24. I need the other two sides. That side is opposite, so my opposite is x. And h is the third side of the triangle, which is the hypotenuse, is y. So the first thing I got to do is find that opposite, because I can't find the third side of a triangle without having the two legs, or the hypotenuse in a leg. So I have to deal with this first. O and A uses tangent. Tan 30 equals O, x over A, 24. Now, if this was algebra and that word tan wasn't there, how would you get rid of that 24? You'd multiply both sides by 24. You're going to do that. Tan 30 is just a number. Where do you get that number from? Your calculator. It knows what the tan of 30 is. So to make sure you do it correctly, because it is impossible to do it wrong if you write it out, you know you've got to multiply this side by 24 to get rid of that and get x by itself. If you multiply the right side by 24, you have to do the same thing to the left side. Tan of 24 times the tan of 30 equals x. Now the only problem here is, of course, whether you have a forward or a backward calculator. Do I know that? No, I do not. Do you know that? Yes, you do. You must know how yours works. Clear? So for me, I have forward calculator, so I just punch it in as I see it. And as I see that, I get 24 tan 30 is, I'm in the wrong mode, degree. Of course, I have checked that my calculator is in degree mode, and it is 13.85. Now, 856, so it's really 13.86. Now, I'm going to need this number again, aren't I? Right? Because I need this number to find that side. So since it's already sitting on my calculator, should I clear this off? No, because it's right there. But if I round it, now I'm going to get a very slightly different answer. Since I know I'm going to use it again, I'm not going to clear it. But I wrote it down just in case I clear it. Then at least I have some kind of answer. Understand? Now, since I know what x is, I also know that x squared plus 24 squared will give me y squared because of Pythagoras, yes? I know that x is 13.856, blah, 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 because it's on my calculator. I also know that I've rounded it right there. So since it's on my calculator right now, I'm just going to push squared. And on my calculator, it will square that number for me. Then I'm going to add 24 squared. On my work, I'm going to write it down. So if I screw up with my calculator, I at least have the information to work with. Now I'm going to add 24 squared, and I'm going to get 768. Right? That's not y, though, is it? This can't be 24 and this 13 and this be 768. None of you would hand that in to me. You remember, oh, right, I got a square root 768. And I get 27.712. And that's where I would like to see the rounding happen. And now I know my two answers. There's one, there's the other. And all I did was one operation on my calculator. And then for y, I did one operation on my calculator. I had to know one thing that was new. That the tan of tangent is opposite over adjacent. That's the only new thing we've done. So now we come down to here, and we were supposed to do 3 more. In this one, theta was x, opposite was 35, adjacent was 50. Since I needed an angle, it was shift tan of x equals 35 over 50. To do that on my calculator, I remember that is just bracket 35 divided by 50, close brackets. Shift tan, 35 divided by 50, and I get 35 degrees. That's how quickly trig works. It's one question. You write out the 3 things, you decide what you're doing, you punch it into your calculator. The only thing you have to know is what the words opposite and adjacent mean. In this one, I had a theta of 60. X was opposite. Adjacent was 7. So tan 60 equaled x over 7. Numbers on the bottom. 7 times tan 60 gives me x. $12.12 was x. Once I have 12.12, how do I find y? Pythagoras. That's going to be x squared, which I know is 12.12, plus 7 squared. And then what do I have to do that whole answer? What do I do at the end of Pythagoras? I square root it all to get the answer. And it is 14, exactly. Then I find my answers there and there. And lastly, if you haven't done these, if you didn't do these like I asked you to do, then you should at the very least be attempting this third one by yourself right now, following the examples that you have now seen 10 times. If you've seen something 10 times, you should be pretty comfortable in the fact that it works. What do I start with? The angle. What is it? 80. Then from there, I choose my opposites and my adjacents. 10 is what I know. Is it opposite or adjacent from 80? Opposite, because I went across the shape. So O equals, not 80, you idiot. O equals 10. What is X? X is adjacent. So now I know that tan is opposite over adjacent. So tan of 80 equals opposite 10 over adjacent, X. Now there's a whole bunch of algebra here to figure this out. Or you can remember when the letter's on the bottom, we divide. All right, I've shown it to you a bunch of times how the algebra works. If you need to see how the algebra works, I can show you. Or you can remember that 10 over tan 80 equals x. How do you enter that into your calculator? Same way you entered that into your calculator. 10 divided by tan 80 equals. Or, if you have a backward calculator, 10 divided by 80 tan equals. Why is the backward calculator a hassle? Because when you hit 80 tan, your screen is going to change. Is that the answer? No, because until you hit equals, your calculator is not giving you an answer. It is just doing work. Does everybody understand? Aiden.
So you divide 10 by tan 80, not
Yes.
tan 80 by 10?
No, 10 divided by tan 80. And this is why. If I gave you this, 20 equaled, 20 is a bad one, 5 equaled 20 over x. How would you solve this? Doing algebra. X isn't allowed to be on the bottom, is it? So I would multiply both sides by x to eliminate that x from the bottom. Agree? So now I have 5x equals 20, yes? And the last step here would be divide by 5, yes? So x would equal 20 divided by 5, which would be 4. Now please notice, what did we start with? 20, 5, and x. So if at the end I end up doing 20 by 5, I'm allowed to make that shortcut in my head. And because we just did conversions. Is everybody cool? All right. That is where you should be right now. If you didn't do it, and I'm not accusing anybody of anything, but I noticed a heck of a lot of writing while I was talking there, so I'm assuming a lot of people didn't do it. If you didn't do it, you should now be able to do this with a triangle. Now, unfortunately, in the real world, when we are walking around minding our business, having to do stuff like build things, are triangles often drawn for us? No. When you have to figure out how to drive your car from here to Red Deer, Alberta, does the road light up in front of you? No, you have to figure out how to get there. So just like then, in real life, you have to take your knowledge and apply it. But it gets a little bit difficult. Everybody should be comfortable when the triangle is drawn for them. But like I say, unfortunately, the real world is a different place. So please turn your page over to 56, and we are going to do some real world stuff on here. You do not need a protractor. You do not need anything like that. You just need something to write with. But we have to talk about two different scenarios. Okay? In the real world, we can measure, I shouldn't have said measure. We define directions in two ways. What is one way I can define a direction? Aiden.
Cardinal.
Which means what?
Northeast, south.
Northeast, southwest. We all know those directions, right? Okay. So we're going to start with compass directions. Because this, again, is a real-world situation. The compass directions are very simple. What's at the top of a compass? North. It's not up. Okay? We have made it up. We have decided that north is up. What's on the right? East. What's on the bottom? South. And what's over here? West. Now, you guys are smart kids. If I tell you that north equals 0 degrees, and we count this way, what is 90? What is east? 90 degrees. What is, the number after 89, idiot. What is south? 180 degrees. What is west? It's a 9 times table, guys. 9, 18,
270.
27, 270. Everybody good? Is everybody cool? All right. Now, I want you all to draw a line. If I were to tell you I am going to walk at a heading of 60 degrees, sketch the line lightly to make sure if you've done it wrong, you can erase it. Where do you think, here is me right in the middle, because I'm the one that has to do the walking. There I am. Where would I be walking if I walked at a bearing of 60 degrees? And I'll wait a second for everybody to give it a shot. All right, everybody's got it? Okay, where would I be going? Here is what I'm going to say. Would I be going up and right, down and left, or up and left? Up and right. This over here would be 60 degrees. Not exactly, as I don't have a protractor, right? That's more like 45. But that's not... 60 would be steeper. it would be down like here. Everybody okay with that? And the 60 degrees is counted from north. So if this is 60, what's in here?
30.
30.
Almost at 90 for some reason.
Now, once I do that, I can now make triangles. Now I can do trig with 30, or I can do trig with 60. Does everybody understand? That is how trig works in directions in the real world. Is everybody cool? Yeah? All right, now you guys try it. I would like to walk from center, because you always have to start in center. I'm going to walk at a heading of 290 degrees. Draw a line at 290 and then make two triangles that I could do trig with if I wanted to. So the first thing, I'm going to walk 290 degrees, and I want two triangles for trig purposes. This 290 degrees is what we call a bearing. You have heard it in the movies all the time. Where's the bad guy's ship? It's at 280 degrees, south by southwest, Captain. That's what they're talking about. Where's 290? Between what and what?
West and north.
Between west and north. So it goes off this way, yes?
Yes.
Okay. Now make the two triangles. One of them is there, and the other one is there, yes? What is this angle in here?
20 degrees.
20. Why?
Because you're going from west as one of the sides, and it's only 20 degrees.
20 to 70. I went to 290, so I went 20 degrees past west, yes? What is this in here?
70.
70. Why? Because the whole thing is 90, and I've used up 20 of it. Is everybody cool? Now, how does this help us in real life? If I tell you how far I walked on any one of these sides, I can then use trig to find out where I am. Does everybody understand? Which is real useful if you end up somewhere without GPS. Everybody cool? Everyone's good? All right, now, the only thing you have to remember is, what if I don't continue to walk in a straight line? What if I told you I walked 5 kilometers this way, so this is 5 kilometers, and then here I turned? What would I have to do right there? I would have to make another one of these, because every time you turn, you have to make another one. Everybody cool? All right. That is bearings. Now, sadly, there is another way that we use the directions. And these are what we call headings. And they're a little bit weirder, but they're almost the same way. A bearing is a number from 0 to 360. A heading is a direction. And here's how we write it. We write it as direction, then an angle, then a direction. And here is what I mean by that. If I said I am going north, 60 east. The first direction is where we start. The angle angle is the amount of adjustment from the first direction, and the second direction is the way we turn. Okay? So if I told you north 60 east, and I wrote it N60E, we would, if we had no options, if it was just north, we'd be walking straight up here, yes? But we're not. We're adjusting 60 degrees towards the east. So if north is 0, I'm going to walk 60 degrees away from north in an easterly direction. So this is 60. What's this? 30. Is everybody cool with those? Yeah? Try one. I'm going to walk south 30 east. Where would that line be? What direction do I start in? Would it help if I drew the three things in the three different colors? Would that help people? What direction do I start in? South. So down here, yes? How far have I adjusted? 30 degrees. Towards which direction? So is that out here to the left or out here to the right? To the right. So I go 30 degrees towards the eastern direction. So this is 30, so what's this in here? 60. Can everybody do these ones? Okay, try one more, because I had to help a little bit with that one. West 18 south. Where would that line be? It's always my favorite when I see people not writing this down who ask for help later. Which way is west? Straight out here. West. I adjusted 18 degrees. Which direction? Up or down? Down. So if this is 18 degrees, then I could do trig with that triangle. What does that make this in here? 72. And I could do trig with that triangle. Does everybody get directions? Great. That's when we're on the ground, yes? Are there any other directions we travel? Up and down. Absolutely correct. So we've covered the ground directions. Now we got to cover up and down. Everybody draw. You don't have to draw it, but I'm going to draw it. There's a person, yes? Since he has gray hair and is incredibly handsome and he's sticking his tongue out, it's me. Everybody cool? All right. This right here is my eye. My eye looks straight, level, horizontally, yes? Everyone agree? Easy peasy, right? So if we were doing trigonometry, I could draw a line there, couldn't I? Because that's where my eye starts. And I'm going to go ahead and draw that green line. Now, let's say my good friend Ryan shoots up a bottle rocket. Where does it go? Up. No. He shoots up a bottle rocket. He's not irresponsible. He would never shoot a bottle rocket at a person. Ever. Would you? I know you would. So have I. Hit my girlfriend in grade 10 in the eye with a bottle rocket. it didn't do much for our relationship. Anyways, Ryan, being a good responsible user of fireworks, will shoot the bottle rocket straight up, yes? When he shoots the bottle rocket up, it will go bang! Up in the air, yes? Where will my eyes go? Up to where that sound was, yes? So it's supposed to be bang, but it's the usual piece of crap thing with my computer, and it's not making the tail on the G. Oh, now it disappeared half the rest of it.
Yeah. Okay.
Bang, with an extra tail. Everybody agree? My eyes obviously will travel up to that, won't it?
Unless you can fly, in which case.
What did I make there? I have now made an angle, yes? Since my eyes went up, we call that the angle of elevation or inclination, which means I go from straight flat to looking up. Where my face is right now is an angle of elevation. Does everybody understand that? Everybody's cool? Yeah? Okay, now, yes?
So looking from the paper to looking up at you. Angle of elevation.
Yes, because your eye is where you start measuring up. Okay? Everybody cool? All right, now Ryan's messing with my head. He's fired a bottle rocket up in the air, but then he has a mighty might, and he drops it on the ground. It goes bang down here. Where do my eyes go? A mighty might's a little firecracker from when I was a kid. I don't know if they still exist. Because, I'm old. Where do my eyes go now? Down. Not green. I tapped on the yellow. What did that just make? Another angle. Did my eyes go up? Down. So it can't be an angle of elevation. What do we call it? Angle of depression. But you're right. No, you're right. Or declination. Everybody cool? Now the problem with this is when we reverse the situation. Because I'm starting and I'm on the ground, yeah? Everybody agree? This is pretty easy to explain. Don't write down what I'm about to show you. But I want you to change the position. I am now skydiving. Everyone agree? I'm up in the air. I look down and I see my good friend Ryan aiming a bottle rocket at me. Right? Now, where is Ryan's angle of elevation? Up. So it would be between here. It's right in there, yes? That's easy. Now, what if I told you, what do I have looking at Ryan? Do I have an angle of elevation or an angle of depression? Angle of depression. So my eyes are looking out this way and looking down. There's the triangle. Where is my angle of depression? Is it A or B? It is B. This is my angle of depression. Now, what's weird about this situation that messes kids up? My angle of depression, how does it compare to Ryan's angle of elevation? They're the same. Ryan's eyes have to look up, however many degrees. My eyes have to look down that same amount. The mistake you guys are going to make is you're going to put the angle of depression in the wrong spot. You're going to tell me that this is my angle of depression because Ryan's angle of elevation, and you want to work within the same triangle. And that is wrong. Is everybody cool? Okay? Everyone's good? All right. So, I'm done. It is 8:46. At 9:15, yes? Back to the, yeah, I'm about to. I'm going to give you now until 9:15, which is half an hour, to do some trig on your own. At 9:15, 9:10, 9:15, I'm going to give you back the test and we're going to go over it. Okay? All right? So, you are going to work on page 57 of your book, which is called page 76 because it goes along with your outline. And you will notice that at the bottom of the page, the answers are there. So you can check and make sure that you're doing it right. All right? All right. Here is all the work. I want you to do that whole page right now. And notice I have used the words angle of inclination, angle of depression. You need to figure some stuff out. These are 11, 14, 19, and 20 are all real life trig problems. These are things that people need to be able to do in the real world with angles and trig. Okay? Go.